It's used for producing continuous power turbine.
Tell me.
It's used for producing continuous power.
Continuous power. Okay. What is the difference between compressor and turbine? Anybody? In the previous class, we are discussing with compressor. What is the difference between compressor and turbines? Slides are visible.
Yes, sir.
Okay. Turbines. Turbines are the major devices in mechanical engineering. Okay. They are work producing or power producing machines. Okay. In case of turbines, the potential energy of water is converted into mechanical energy by means of rotation of shaft. Okay. Which in turn converted into uh, the electrical energy. Okay. Electrical energy, whenever the electrical generator is connected to the shaft, we get the electrical energy. This is how the conversion of energy takes place in case of turbine. We are having different types of turbine. One is hydraulic turbine, second one is steam turbine, and third one is gas turbine. In hydraulic turbines, the working fluid is water. In case of steam turbine, the working fluid is steam. And in case of gas turbine, the working fluid is air or gas. Okay, so here we are dealing with the hydraulic turbines. Before that, just I'll give the classification of turbines. First one, based on the flow of water. Okay, how the water flows in the turbine. First one is impulse turbine. Second one is reaction turbine. In case of impulse turbine, only kinetic energy of water is available at inlet. Example is your Pelton wheel or Pelton turbine. Second one is reaction turbine. In case of reaction turbine, both kinetic energy and potential energy available at inlet to the turbine based upon the head available at inlet to the turbine. Okay, one is low head turbine, second one is a medium head turbine, and third one is a high head turbine. In case of low head turbine, the head available is 0 to 50 meter. And key example is low head turbine. Can you give any example of low head turbine? You are studying the turbo machines, right? You are drawing velocity triangles and those things. Can you give what is the example of impulse turbine? Pelton wheel is the example of impulse turbine. Okay, only the kinetic energy is available at the inlet to the turbine, and it is also uh, the tangential flow turbine. Okay, second one is based upon the head available. Low head turbine is the head available is between 0 to 50. Example is Kaplan turbine. Second one is medium head turbine. The head available is above 50 meter and below 400 meter. Okay, and then in case of high head turbine, the head available is above 400 meter. Okay, example is our the Pelton wheel. Okay, and third one is based upon the direction of flow with respect to the runner. Okay. First one is tangential flow turbine, where the water enters in a tangential direction to the runner blades. Example is Pelton wheel. Second one is radial flow turbine, where the water enters and leaves radially from the turbine. Example is Francis turbine. And third one is axial flow turbine, where the water enters and leaves axially from the turbine. Example is Kaplan turbine. And fourth one is mixed flow turbine. That is where water enters radially and leaves axially from the turbine. Example is modern Francis turbine. Okay, in a fluid mechanics lab, we are having three turbines. One is Pelton wheel, second one is Francis turbine, and third one is the Kaplan turbine. Okay, today we'll discuss Pelton turbine. Okay, this is a Pelton turbine. What you are seeing on the screen. Okay, this is first part is it is called as a casing. Okay, in the inside the casing we are having a rotor. That is a large disc. Okay, you can see the large disc. On the periphery of rotor, we are having the equally spaced turbine blades. Okay, they are the hemispherical cup-shaped bucket. Okay, so here first one is casing, second one is your rotor with a turbine blades. Okay, we are having around 32 to 64 number of the blades fixed on the periphery of the runner. Okay, and next, we are having the important part called as nozzle. You remember, we are having the nozzle in case of Pelton turbine. The nozzle does not exist in case of Francis turbine and Kaplan turbine. So, nozzle, the main function of the nozzle is to increase the velocity of working fluid. Already studied nozzle in thermodynamics. Okay, with the expense of pressure energy, the velocity or kinetic energy of the fluid increases. That is nozzle, and we are having is the motor connected to the nozzle. Okay, the nozzle with spearhead arrangement. We are calling it a spearhead arrangement. Okay, to control the flow of water. Okay, so the construction it consisting of a runner or rotor. On the periphery of the runner, we are having the cup-shaped bucket. You see the shape of the bucket. This is the blade shape in case of Pelton wheel. But we are not having such kind of shape in reaction turbine. That is in case of Francis turbine and Kaplan turbine. Okay. Can you tell me what is the shape of blades in case of reaction turbine? Anybody? What is shape? Shape of blades in reaction turbine. So we are calling it as the aerofoil shape. Okay, but in case of Pelton turbine, we are having the double hemispherical cup-shaped bucket, or it is also blade. Okay, the why the structure is that whenever the water impinges on the blades, it distributes equally in both the directions, in all directions. Okay, that's why the shape is like this. Okay, that is double hemispherical cup-shaped bucket. And we are having 30 to 64 number of the blades, and this one is a spearhead with a nozzle arrangement. The nozzle is mainly used to increase the velocity of working fluid, and spearhead, this whatever we are having, this is called a spearhead. The main function of the spearhead is to control or to regulate the flow of water. And one more important thing is Pelton wheel is the tangential flow turbine. Here the water strikes the blades in a tangential direction. Okay. Hence, the Pelton wheel is impulse turbine because only the kinetic energy is available at inlet. Second one, it is a high head turbine. Pelton wheel high is high head turbine. Okay, and then tangential flow turbine. Okay, this is the characteristic feature of uh, Pelton turbine. So this is a Pelton turbine. Remember, such kind of structure we are having in our FM lab. Okay. And, regarding to the working principle of Pelton wheel. Okay. So the water from the dam enters into the penstock. Penstocks are very big pipes, and from the penstock, the water enters into the inlet to the turbine. Here, inlet to the turbine, and then where this water consisting of potential energy, okay, then that potential energy is converted into kinetic energy when the water hits to the buckets or blades of the turbine. Hence, the potential energy of water is converted into kinetic energy first. Okay. So, whenever the water hits or strikes the blades at a high speed, okay, the runner or rotor, okay, starts rotating. Okay, and we are having the shaft, okay, shaft connected to this runner or rotor also starts rotating. Hence, the first potential to kinetic, then kinetic to mechanical. Mechanical means rotation of the shaft takes place as the rotor starts rotating. Next, the mechanical energy is converted into the electrical energy. So, whenever the water hits on the periphery of the turbine blades, so it will be converted into kinetic energy into the mechanical energy by means of rotation of shaft. Okay. And then the mechanical energy is converted into electrical energy whenever the electrical generator is connected to the shaft. Then after performing the work, okay, the water discharges through the tail race. This is how the construction and working of the Pelton turbine. Working principle is very simple. Okay. First, the water from penstock enters into the inlet to the turbine. Conversion of potential energy to kinetic energy. Then the water enters in tangential direction. You remember, okay, in the Viva they may ask, so what kind of turbine it is? It is a tangential flow impulse turbine of high head. So whenever in this what structure you are seeing, this is called as nozzle. The nozzle increases the velocity of working fluid, then it impinges on the blades of the turbine. The blades are double hemispherical cup shape and they are 32 to 64 in number. Okay. So when this nozzle issues the water with a very high velocity, the blade starts rotating. The rotor also starts rotating because the blades are connected to the rotor, and then the shaft also starts rotating. We cannot see the shaft here. Okay, it is at the back. This is the whatever structure you are seeing. This is the shaft. Okay, it is at the back side. Okay, shaft start rotating. So there will be conversion of kinetic energy into mechanical energy by means of rotation of shaft, then mechanical energy into electrical energy when the generator is connected to the shaft, and then after performing the work, water discharges into the tail race. You remember in case of Francis turbine and Kaplan turbine, we are having a part called as a draft tube. Okay, here, draft tube is not there directly after performing the work of water discharges into the tail race directly. Okay, this is the construction and working of the Pelton wheel. The application of Pelton wheel. Pelton wheel are preferred turbine for hydropower when the available water source has relatively high hydraulic head. Okay, hence it is a high head turbine. The smallest Pelton wheel are only few inches across and can be used to tap the power from mountain streams having the flows of few gallons per minute. Okay, whenever the high head is required, the Pelton wheel is applied. Okay, the construction and working of. So what you are seeing, it is a nozzle with guide mechanism. Okay, so here this one is nozzle. You can see the nozzle here, and here what we are having is a spearhead. Spearhead is to control or regulate the flow of water, and what you are seeing, it is called as nozzle. The main function of the nozzle is to increase the velocity of the working fluid. And this is a sketch of your Pelton wheel. So this is the casing. We are having a runner on the periphery of the runner. We are having the equally spaced double hemispherical cup-shaped bucket. And so what I talked is penstock. Okay, penstock, and this is the spearhead with the nozzle arrangement, and this is the nozzle and wheel. Next, this is your tails race. Tail race. If after performing the work, water discharges into the tail race, and this is a tangential flow. Hence, it is called as tangential flow by head turbine. So this is the sketch of the Pelton wheel. Now come to the experimentation. Hope you understood the construction and working of Pelton wheel. Today we are going to conduct experiment on Pelton wheel. We have conducted experiment on reciprocating pump, centrifugal pump, air blower, air compressor. Okay. So now the last part of FM lab is turbine. Okay. There are three turbines. We are having all these turbines in our lab. Okay, this is what you are seeing. This is your Pelton turbine. This is runner with the buckets. It's a load indicator by changing the load. And this one is our RPM indicator, etc. This is our tail race. After performing the work, the water discharges into the tail race. And what you are observing here, it is the nozzle with spearhead arrangement. Okay, it's the flow control valve we are having. This is the experimental setup of Pelton wheel. Okay, the aim of the experiment is to conduct experiment on Pelton wheel and to find out the performance parameters. Here you are going to find out the efficiencies. Okay. And there are two set of operation here. Okay, one is a constant head and second one is constant speed operation. So we are going to keep the head as constant and varying the speed. We are going to find out the performance characteristics. Okay, so we are going to change the load and also the speed. Okay, as the load changes, speed also changes, but keeping the head, that is pressure head constant, we are going to find out the performance characteristics. And then second one is there, that is constant speed operation, where the speed is kept constant and changing the head, that is constant speed operation. Okay. And in the exam, they may ask either constant head or constant speed, not both. Okay, remember. So we are having two sets of operation. They'll give clearly. Okay, perform the experiment on Pelton wheel at constant head. Okay, and then perform experiment on the Pelton wheel at a constant speed. Okay.
In exam, I have to do both, sir.
No, no. Uh, water, what?
Like for exam, I have to do for both constant head and speed, sir.
No, 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 no. We'll give anyone in the
Okay,
exam. Okay. But
sure.
in the record, you have to write both.
Okay.
In the record, you have to write both constant head and constant speed. And but in the exam, you'll get only one, either constant head or constant, not both.
Okay.
Anybody, you studied unit characteristics? No, what do you mean by unit speed, unit discharge? Anybody? I think you studied in turbo machine. What is unit speed? Okay. First, all of you note down this constant speed operation. Okay. Constant head. Sorry. Don't write both the tables. First, you write this table. Okay. Constant head table. To perform the experiment on Pelton wheel at constant head, and also gate opening. So we are having the four gate opening, that is a half gate wall opening. Sorry, 1/4 first. Next we are having the half gate wall opening. Next 3/4 gate opening, and then last one fully gate opening. So these are all gate openings. Okay. So in the four cases we are having the different readings. Okay. All of you have to note down this tabular column, what you are seeing on the screen.
So what is gate openings actually?
Gate opening means we are having walls, right?
Yes.
Okay. Whenever you open full wall, no, this complete wall opening means it is 360-degree. Okay.
Yes.
And then we are having this one 90-degree means 1/4 gate opening. 180-degree wall opening means half gate opening.
Okay.
Next, 270-degree opening means it is 3/4 opening.
Yes.
Like that, we are having settings in lab. Okay, these are the four gate openings.
Okay.
I'm going to give totally 4 into 4, 16 readings are there. Okay, for one opening, we are having the three readings. Okay, can take three readings enough. 3 into 4. Okay, better you take four readings. Four readings are there. Okay, you make four rows for each gate opening. 4 into 4, 16 readings. First, you write this tabular column. So after that, I'll give the calculated tabular column. Okay. Can I give two also opening only for constant head and constant speed? Okay, totally you can do it. Hmm. First, you note down this tabular column, trial number, gate opening, pressure gauge reading, and kg force per centimeter square, speed in RPM. Okay. Speed in RPM in constant head, the speed varies, and in constant speed, speed remains constant, and the head vary. Head over the notch. Okay, you see, we studied the notch experiment. The main purpose of the notch is to find out the discharge of flowing water. That is the function of notch. We're having the initial head in meters, final head in meters, and difference H2 minus H1 in meters. Okay. Then load applied.
Sir, how many readings?
Actually, there are 4 gate openings.
For each gate opening, how many?
4 readings are there.
16, sir, total.
Total 16. Okay. Otherwise, what? Okay. Because we are having constant head also, constant speed also. Okay. Two things you have to calculate here. Calculations are more. Okay. More calculations in turbines. You remember? Okay. Tabular column, calculations, even graphs are also more. Okay. Okay, first write down this constant head. Next, after writing this one, have you finished this one or do you note down this one?
Finished, sir.
Okay, you after that you have to write this tabular calculated tabular column. You see constant head. First column only you have to write. Okay, not don't write second one. So immediately after writing table of observed readings, you have to note down the table of calculated values. Okay. Trial number, discharge, input head, input power PI in kilowatts, brake power means output power, efficiency in percentage, and you have to find out the unit quantities. Unit quantities, one is unit speed, unit discharge, and unit power, and also the specific speed. I think you might have done derivation on specific speed in case of turbine in the first chapter of turbo machine. You are going to find out all the parameters. First you write down tabular column, second you write down constant head operation, only the first table. Don't write second table because second table is related to the constant speed operation. Okay. First one I am giving constant head operation. All of you note down the calculation turbines. Okay, most important. Uh, all the turbines, same calculation. Try to understand one turbine properly. Any one turbine. Okay, same calculation, same tabular column, same thing for all the turbines. All of you, please note down the first tabular column. Okay. Just you do the calculation in the calculator and put it in the tabular column. No need to uh, show all the calculation. You have to show any one specimen calculation. Remaining thing just you have to put it in this tabular column only. Constant rate operation and constant rate operation for 90 degree, for 180 degree, for 270 degree, and for 360 degree. Is that finished tabular column? Okay.
That done, sir.
Okay. We know now next note down the constant head characteristic. This one calculation. In the calculation now for constant head. Okay, you note down this formula. Okay, first you have to calculate the discharge. Loss of head is small h into Sg minus Sw. Okay, Sg is specific gravity of mercury, that is 13.6. Okay, just you neglect. Okay, we don't have units for this one. Only 13.6. H2 is specific gravity of water as 1. Okay, and small h is your difference between two head. I am giving the readings now, H1 and H2. Next, you have to calculate discharge A1, A2 square root of 2GH divided by A1 square minus A2 square. Okay. Next, input head, you have to calculate N into P meters. Okay, whatever pressure gauge reading you are having, suppose for 2, you have to convert into input head as multiply by 10. Okay, that is given in kg force per centimeter square. And what we are getting, it is in meters. Okay, multiply by multiplication factor is 10. So 10, suppose if 1.5, you have to take 15 meters. If it is 2, you have to take 20 like that. Next, PI is input power WQ into HM divided by 1000. W is your specific weight. Specific weight is rho into G. Rho is 1000 density of water into G is 9.81. All of you note down this formula. So same simple formula. That is, one is discharge, one is input power, brake power, and then overall efficiency. That's it. And brake power is 2 pi nt divided by 60,000 kilowatts. T is torque. That is F1 minus F2 into 9.81 into R. Okay. That is F1 and F2 are in kilograms. That's why you have to convert in Newton meter. F1 minus F2 into 9.81 into radius of the brake drum. Radius of brake drum is 0.15 meter, remember. F1 and F2 readings I'll give. This torque is given by F1 minus F2 into 9.81 into radius. And N is the speed of the RPM. In case of constant head operation, the speed vary. Okay. Divided by 60,000 kilowatts. Done, na? So, okay. So after that, you have to calculate the unit quantities in constant head. We are having the three unit quantities. One is, sorry, four unit quantities, unit speed. Nu equals to N divided by square root of H RPM. Unit power, okay. P divided by H to the power of 3 by 2. And QU is unit discharge, Q divided by square root of H. And fourth one is specific speed. That is N square root of P divided by H to the power of 5 by 4. Can you tell me what is specific speed of pump? You derived the derivation. Anybody? Specific speed of turbine is N square root of P divided by H to the power of 5 by 4. What about specific speed of pump?
So n square root of q divided by
No. In the Viva questions, they may ask define unit quantities and the specific speed. What is the difference between a turbine and pump? Okay. So these are the four formulas you should remember. One is unit speed, N divided by square root of H, P divided by H to the power of 3 by 2, QU equals to Q divided by square root of H. And fourth one is specific speed is N square root of P divided by H to the power of 5 by 4. Then we are
So
having, tell me.
one is remaining
No. Which one? Efficiency.
from input power source remaining.
Okay. Take. Down. That in turbines, calculations are most important. Try to do the calculations correctly. Okay. Or okay, last you write down this also unit quantities. Equation of unit speed N square root of H, N divided by square root of H.
இல்லையா இல்லவா அப்போது
Srivas, mute yourself. Okay. Mute your audio. Can I give the readings now? Okay. Okay, I'm giving the readings in the chat box. Okay. For constant head operation. Okay. Okay, I said constant head for 90-degree gate opening. 1/4 gate opening. First trial, pressure 2, that is 2 kg force per centimeter square, speed is 992 rpm. You remember that P2 minus P1, okay, P1 minus P2 remains same for all the readings because it is a constant head, point 2 only you have to take. And F1 and F2 for calculating the torque. So this is a 90-degree gate opening. Now I am doing 180-degree gate opening. So you have to take head as 0.3 centimeter for all the reading. All of you note down the readings, whatever shared in the chat box.
So it should be H1 no, sir, actually.
And
It should be H1, H2 no, sir.
then H2,
Not P1, P2 no, sir.
H2. H1, H2. Please take it as H1, H2.
Yes.
And head toward the notches, that is H, that you take H only, that one. H is 0.2 centimeter.
Okay, sir.
For all the readings, 0.2 only because it's a constant head.
Yes.
For the for one setup, we are having 0.2 centimeter. Next setup, we are having 0.3 like that. Okay. You
Okay.
take H as 0.2 only for all the readings.
Yes.
Second trial, okay. And that's why I'm giving H as 0.3. Normally you take for first trial 0.2 centimeter only H. Okay, for second trial you take only H as 0.3 centimeter. Devasan, please mute
Yes,
your
sir.
audio. Please mute your audio. So I gave two set of reading for constant head, okay, for 90-degree gate opening and 180-degree gate opening. Okay, this is for constant head. Okay, I'm not giving 16 readings. I'm giving only eight readings for constant head and 8 readings for constant speed. I'll give. Okay, so you do this much, only 2 gate opening you do it, and remaining 2 gate opening I'm giving for constant speed. Okay, should know.
So what's the pressure?
Huh?
Pressure?
No, I gave the readings for constant head for two gate openings only. Okay, for 90° and 180°.
Okay, sir. And
In the
pressure
meantime, so you have to do the gate opening for because otherwise, shall I give the readings for all this one gate opening for constant head? Means totally you have to do 32 calculation. Okay, 16 plus 16.
that's the best give all.
All, okay. Okay. So for 270, I'm giving now 270° gate opening. So
Sir, 2 readings only enough, sir.
what?
2 readings only, 2 gate openings only enough, sir. 16
Okay.
can.
Because you are having constant speed also next. That's why.
Yes, sir.
Simple calculation.
So pressure gauge is constant, sir. 2, sir, for all reading.
For all. For
Okay, sir.
for constant head is constant. For constant speed it vary. Okay. For constant
Okay,
head
sir.
it is same. For
Constant.
okay.
Okay, sir.
2 kg force per centimeter square, and we are keeping constant.
Yes, sir. But in exam, I'm only one calculation, no, sir.
This one set will give one set.
Okay.
Now, all of you have to note down the constant speed tabular column. Okay, first you note down all the readings. Okay. First you note down all the readings. After that, the first one, second one, you have to note down the constant speed tabular column. Okay. I'm not giving all 4. I'm giving only 2 gate openings. Okay, 90° and 180° for constant head, and remaining 270° and 360° I'm giving for constant speed. Okay, so now next you have to note down this tabular column, constant speed. Try to understand one calculation. You will get easy calculation. Okay. And here in speed, same thing. Okay, same tabular column, only the speed varies. But the speed remains same and the head vary. And in case of constant head, the head remains same and speed vary. That is the difference. And remaining tabular column is same. Okay. Next, all of you have to note down the constant speed tabular column.
Sir, the second trial that you've given for 180° gate opening, you've given H twice.
H twice, huh?
Yes, sir. Like the first trial, you've given speed as 973, and after that again you've given H. But before that, you've given H1, H2, H3 values.
Right. For first trial, huh?
Second, sir.
Trial. Second, H1 is, you have to take this 0.3 centimeter here, no?
Yes, sir.
This is common for all the readings. Okay, in H1 column you have to enter 2 centimeter and H2 column 1.7 centimeter for all the trials you have to enter.
So for P, what should we put? P value for
P is
second.
2 is constant. Like, you know, first trial pressure equals to 2 is there, no?
That's for both first reading and second.
If pressure, you take 2 kg force per centimeter square only for both the readings.
Okay, sir. Okay, sir.
Okay, next, you note down this constant speed operation. Is a tabular column is same. Okay, no change. Only in calculation part, so you are having little bit difference. Okay, so in constant speed, no need to calculate all the unit quantities. Only you have to calculate the head, input power, brake power, and efficiency. Only in case of constant head, you are going to calculate all the unit quantities and specific speed. But in case of constant speed, first you note down tabular column for constant speed. The second tabular column, what you are seeing on the screen, this one you note down, and calculated tabular column don't include unit quantities and specific head. Okay, only include the remaining thing, like you have to calculate head h, next you have to calculate discharge, next input power, output power, and efficiency. That's it. All of you note down this tabular column. Okay. Okay, it is similar to your constant head only. Note down. Okay, and here calculations part. Same calculation. Okay, no change. Same formula you are going to apply, but don't calculate the unit quantities. That's it. Remaining thing is same as that of your constant head. Okay. See, discharge you have to calculate, input head you have to calculate, input power you have to calculate, brake power, and out efficiency. Okay. Now I'll give the readings for the constant speed. Okay. Constant speed, we are keeping the turbine at constant speed, running at constant speed, only changing the head. And in case of constant head, keeping the head constant and changing the speed of the turbine. Constant speed operation. Speed N is 900. Okay. 900 RPM, keeping constant RPM for all the calculation for all the trials. Okay. First trial. Now I am giving the readings for 270 opening and 360 opening. Okay. Okay, now I shared the constant speed operation. Keeping sometimes they make you the speed as 1000 RPM or 800 RPM. Depending upon this one, you have to calculate the things. Okay, here keeping the speed of the Pelton turbine as 900 RPM. And for 270-degree gate opening, I am sharing the details. Pressure is 1.6 for first trial. N is 900 RPM. Head over the notch 0.5. F2 minus F1 is 0.7. Next, second trial pressure is 1.8. Now I am giving for 360-degree gate opening for constant speed. Okay. Again, you take N as 900 RPM only for all readings.
Can you H1, H2 no, sir?
H1, H2 directly I give. Okay.
Okay, sir.
H1, H2 is 0.5 first reading. Second trial is 0.5. And third
Yes.
trial is 0.2.
Okay.
Note down the readings because in the exam you should know the calculations properly. Okay, especially in turbine, most important. Everything they'll check. What is the constant head, constant speed, the specific speed. What is the efficiency? Also most important. Okay, so do the calculations correctly. Okay.
Sir, so in this constant speed readings, initial head and final head, we don't have to take those two columns.
No, directly I gave. There is a point. Is there in the column? Actually, it's there in the readings.
Yes, sir, we'll not write. We'll cancel. And
Yeah,
what's the
yeah.
reference angle, sir? Angle, what is the?
Which one? Last one.
Only 270-degree you have given now, sir.
I gave
So what-
only two readings for constant head and two opening for constant speed. Like that, I gave. That's why I asked. No, you want all means I'll give you everything. Okay, all the four means you have to calculate 32 calculations.
No, sir, in constant speeds, constant speed is 900. So the valve, I mean, the gate opening, how many degrees? Only 270.
No. We can take for this one 90 also, 180 also. Okay.
We are
We
not
have
taking,
all the
sir.
readings, but I am giving only two readings. This only for 270 and 360 degree I am giving. Okay.
Okay, sir.
But in the exam, we can get any gate opening. Okay, either a 180, 90 degree like that. Okay.
Okay, sir.
In case of constant head, we are having four gate openings: 90, 180, 270, and 360. In constant speed also, we are having 90, 180, 270, and 360 degree. Okay. But in the exam, you can get either constant head or constant speed for any gate opening. Okay. Remember.
Yes, sir.
Out of this one, you may get anything.
So can you show the observations 1 second?
Observations for what? Constant speed.
Yes, sir.
Okay, these are the things you have to take. I gave readings directly S2 minus H1. You can enter that one. Okay. Don't enter this one H1 directly in the tabular column. You skip these two steps. Directly you put H2 minus H1 only. I gave readings. Okay. This is the constant speed a tabular column. Observations. What you are having? This one only constant speed. Okay. Head over the notch, directly you put H only. I am giving H2 minus H1 only directly. I am not giving readings separately for H1 and H2. Directly I am giving the final head only. You enter that one only. Here, understand this experiment properly because it's a very this one big calculations. You are having lot of calculations, graphs, everything. That's why I try to understand this experiment properly. Now I shared readings for 360 degree. Okay. So now I shared two gate openings for constant head and two gate openings for constant speed. In the exam, you may get either constant head or constant speed for any one gate opening. Okay. You remember, not all gate openings, only one gate opening you have to perform in the main exam. But in the lab record, you have to do all the calculations, what I gave. Okay.
So what are the diameters of pipes?
Pipe A1 A2, right? Okay. You take a D1 as 50 mm and D2 as 25 mm. In calculation part, okay. D1 is 50 mm. Okay, bigger diameter is 50 mm. Okay. And smaller diameter is 25 mm. you have to convert mm into centimeter. That is, you are having now CD equals to A1 into square root of 2gh. In A1, pi by 4 into 50 into 10 to the power minus 3 whole square. That is A1. A2 is pi by 4 into 25 into 10 to the power of minus 3. Don't take mm directly. You have to convert mm into meter. That is pi by 4 into 25 into 10 to the power of minus 3 whole square. That is how to calculate A1 and A2. Jayant understood that observations? Yes, sir. First, you write the tabular column properly, note down the readings properly, and first you do one calculation properly. Okay, remaining you'll get easily. First, you do one calculation in constant head and one calculation in constant speed. Try to get the correct answer. Okay, once you get remaining thing, easily you can calculate.
Sir, head value
Which one?
360
Which
degree.
one? 360 degree H value. Huh?
Yes, sir.
But third trial didn't give sir.
H value is 0.2 for a second trial. Third trial, H value not given. Okay. Third trial, H value take 0.2. Okay. Just you do one calculation in constant head and one calculation in constant speed. Tell me the answer so that if it is correct, you can proceed with the other readings. Any doubts? ಪ್ಲಾಸ್ಟಿಕ್ ಇದು ಅಂದ್ರೆ ಸರ್ ಹತ್ರನೇ ಇರ್ಬೇಕು ನೋಡಿ ಇಲ್ಲಿ ಒಳಗಡೆ ಅದೇನ್ ಕೊಟ್ರ ಇಷ್ಟು ಕೊಟ್ಟಿದ್ದಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ ಕ್ಲಾಸಸ್ ಹೇಳಿದ್ರೆ ಫಸ್ಟ್ ಇಯರ್ please give your attendance. Sai Sumant. Present, sir. Abhishek GL, he was present. Abhishek GL. Sai Sumant present. Okay, okay. Abhishek GL. Abhishek Haniur. Adarsh Desai. Ajay Kurut. Akram Anwar. Akshay Jadhav. Alap Mundayur. Alap. Ankit Nambihar. Astesh Nadella.
Present, sir.
Vibhan. Chinmay Prasad.
Present, sir.
Doing the calculation, Chinmay.
Yes, sir.
How much you are getting? Have you got any answer?
Still doing, sir. Still
Do
doing,
it.
sir.
Chandan Sarup. Karishma.
Yes, sir.
Karishma doing calculation.
Yes, sir.
Darshan. Darshan
Present, sir.
absent. Okay. Darshan, how many experiments you completed, Darshan?
Sir, I've done most of them. Only
Because
last
no,
week I'm right.
only 3 weeks left out. In 3 weeks, you have to finish all the experiment, all the labs. Okay. You remember, you are having 100 marks for lab. Okay.
Sir, 3 weeks for what?
So,
No, another
3 weeks.
3 turbines left out. After finishing this one, you have to come submit your record. You are having lab internals, everything. Okay.
So we don't have offline labs, sir.
Still, we have not received any information. Okay.
So, Alap is present. I had to just go out for 5 minutes, sir.
Okay, okay, no problem. I'll give the attendance. Okay.
Okay, sir.
Ibad Kausar. Govindraj. Jayant Reddy. Guda Jayant Reddy.
Present, sir.
Doing calculation, Jayant Reddy.
Yeah, yes, sir.
How much you got efficiency?
Still doing, sir.
Still doing, do it. Tell me the answer after completion. Purushottam Reddy.
Okay, sir.
Purushottam Reddy. How are you, Purushottam
Present, sir.
Reddy? Okay.
Fine, sir.
Attending all the classes regularly?
Yes, sir.
Okay. How many you finished lab these experiments? Purushottam Reddy.
Sir.
How many experiments you finished in the lab record? Tell me.
Sir, I written 5, sir.
Then you had to submit, no, in the classroom. Huh?
Yes, sir. Okay, sir. I will submit.
Today submit it, okay?
Okay, sir.
Rutik Shah, Jayan Bansali,
Present, sir.
Jitin Kumar V.
Yes, sir.
Jitin, how many experiments you uploaded?
5, sir.
Only 5. Totally 11
Yes,
or
sir.
including today's this one, okay? Finish remaining experiments.
Yes, sir. Okay.
Srivasan.
Present, sir. Present, sir.
Okay. So note down all the readings properly. Okay. If still you have any doubts, ask me. Okay, I'll clarify. Do the calculation. Suppose you're having any doubts in the calculation, ask me. Okay.
So what's the value of A1 and A2, sir?
A1, A2 is D1 is 50 mm. Okay. D2 is 25 mm. A1
Okay.
is 5 by 5. I'll give the answers. A1 is 1.96 into 10 to the power of minus 3 meter square. Okay.
Okay, sir. Yes, sir.
And A2 is 4.9 into 10 to the power of minus 4 meter square.
Okay, sir.
How we are getting, D1 is 50 mm, 5 by
D2.
4 into 50 into 10 to the power of minus 3 whole square, A1. A2 is
Yes, sir.
5 by 4 into 25 into 10 to the power of minus 3 whole square.
Okay,
Like that
sir.
you have to do. That is the calculation for A1 and A2.
Okay, sir. Thank you, sir.
So you try to understand this experiment properly. Remaining experiments, that is Kaplan turbine and Francis turbine, same tabular column, same calculation, no change. Okay. That's why try to do this calculations properly. And remaining experiment also in Francis turbine also you're having constant head, constant speed. In constant head, you have to calculate unit head, unit speed, unit discharge, and specific speed. And in case of constant speed, just you have to calculate the efficiency. That's it. And for Kaplan also same thing. Okay. Anybody have got any efficiency? One answer from constant head and constant speed. Anyone tried? And Bansal, how much you are getting efficiency?
Sir, I'm not able to get it.
Which one? Which one you are not getting?
Efficiency. I'll try it again and check it out.
No, you tell me where you made mistake.
That is what I'm finding out now, sir.
That's why unit conversion. Okay. Do the calculations correctly. Okay. And those who have not completed the record, complete it and submit it in the Google Classroom.
So what's the efficiency answer for
How much you are
first
getting? Tell me. I'll tell the range.
I'm
Around
getting
40.
output power more than input power, sir.
No, you should get the output power should be less than your input power. Okay. How much you got? Tell me. Around 46, 45. I think you made a mistake in units only. You are getting in the range of 4.9 into 10 to the power of minus 4 for first reading you. Into minus 4 you are getting. Q. Next, PO will be less than that of PI. Around 0.4, 0.13 is your output power and 0.4 is your input power. Efficiency is around 45-46% you'll get.
So what is discharge value?
It is first value 4 point. How much you are getting? Into 10 to the power of minus 4 something you get. That
I'm
is
getting 3.56 into 10 power
minus 4, right?
Yes, sir.
Correct. It's correct. Now, how about output power and input power? Output power will be less than that of your input power.
So what is input head, sir? 20 meters.
20 meters.
10 into P.
10 into 20 only. 10 into 20 only. Correct, sir. Input header. Getting correctly output power and input power, size Suman?
No, sir.
No. How much you are getting? Tell me. Output power and input power.
Input I'm getting 0.069.
Output more, right?
Output more 0.09.
That output power is have multiplied by 0.75.
No, sir, I did according to the formula given.
Just a minute.
By NT by 60,000.
Okay, I'll share this calculation in the Google Classroom. Okay, just you refer it.
Yes, sir.
Yes. Okay, I'll share all the calculations. Just you go through and analyze it. Okay, I'll stop the recording now.